Hello. Well, for the last 54 pages of James Stewart's Calculus 6th edition, I've been pulling my hair out with logarithms, natural logarithms, exponential functions, and and he does it twice. He does it first from a more intuitive, pre-calculus approach, and then he does it from a more rigorous, I want to be a math major approach. And, I'm just going crazy. And so I felt like I wanted to do one more video where I basically, and now da 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 da, we see who's died in the last 54 pages, and who knows how many months I've been going through this. Well, here we have it. Some things on exponential functions and logarithmic functions and natural logarithmic functions from James Stewart. Laws of exponents. Okay, so a base, and here we're talking about a constant, raised to a power that is the addition of two things, is equal to the product of a to the first one times a to the second one. If we have a base raised to x minus y, that's the same as a to the x divided by a to the y. If we have a to the x all raised to the y, that's the same as a raised to the x plus y. Then if we have two constants, a times b raised to the x power, that's the same as the first constant raised to the x power times the second constant raised to the x power. Laws of exponents. Okay, what about the derivative and integral of the exponential function? The exponential function is a constant raised to a variable, opposite of the power function, which is a variable raised to a constant. Anyway, so if we have a to the x, what's the derivative of it? Why, it's a to the x times the natural logarithm of the base. Okay, things to remember. What about the integral? Well, the integral is going to be a to the x over the natural logarithm of a, because then if you take the derivative of it, the natural logarithms will cancel out and you'll get a to the x. So the integral of a to the x is a to the x divided by the natural logarithm of a plus a constant, as long as a doesn't equal 1. Okay, so there you have the derivative and integral of the exponential function. What about the natural logarithm e, natural number e, 2.718281828, blah, 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 blah. What about it? Its derivative and its integral is equal to itself. And so the derivative of e to the x is e to the x. By the way, if x is something other than x, like if x is x squared plus 1 or whatever, you also have to multiply it by the derivative of that x, whatever it is. But in the case of just x, the derivative of x is 1. So, you didn't even know that we multiplied this by 1. So you do have to take into account that kind of chain rule stuff. But as a starting point, the derivative of e to the x is e to the x, which means, of course, therefore, that the integral of e to the x is e to the x. And I'm sorry, PowerPoint sometimes fails me. Let me hold that thought. There it is. The universe is fine now. So the integral of e to the x is going to be e to the x plus a constant. Okay. What about the natural logarithm, which is the inverse of e to the x? Well, the derivative of the natural logarithm function is 1 over x, which therefore the corresponding integral, the integral of 1 over x is going to equal the natural logarithm. That's not really the corresponding integral, but anyway, you get what I'm saying. Back and forth, back and forth, back and forth. Okay. The exponential function, a to the x, has an inverse, which is the general logarithmic function. And as I sung in my video, the log is the power. So y, the log of x, is the power, such that if I were to raise a to y, I would get x. These are inverses. The exponential function always goes through 0, 1, and the logarithmic function always goes through 1, 0. Okay, change of base formula. Log base a of x can get complicated. So knowing that whatever a is, maybe it's 2.7. The logarithm base a of x is equal to the natural logarithm of x divided by the natural logarithm of a. So this is a helpful formula. Also, what is the derivative of a general logarithm? Well, it's going to be 1 over x times the natural logarithm of the base a. Things to know. This is a summary of the things that you need to know. Lastly, steps in logarithmic differentiation. We learned in this section that it's very helpful sometimes when you have something that looks horrible, it's like deathly, that you have to find the derivative of. that if you take the natural logarithm of both sides and then differentiate, that it can really make things more simple. So if you have a really complex equation, take the natural logarithm of both sides and then use the proper properties of logarithms to simplify, then differentiate what's left implicitly with regard to x and solve the equation for y prime, or the derivative. And there you have this summary of these 54 pages that we've been doing on logs, natural logs, and the exponential function. Don't you feel better now that you know what you really need to know from these pages?